I scored a 132 on the chemistry physics section of the MCAT, and here are 10 chemistry equations you must know. Number one is the ideal gas law, which is of course that the pressure of an ideal gas multiplied by its volume is equal to its number of moles of gas multiplied by the ideal gas constant R multiplied by the temperature in Kelvin. Number two is that pH is equal to the negative log of the hydrogen ion concentration. Very useful and very common. Number three is the famous Henderson-Hasselbalch equation, which allows us to calculate the pH of a buffer solution. And this one goes pH is equal to the pKa plus the log of the concentration of the conjugate base divided by the concentration of the acid. Number four is a useful equation that relates the Gibbs free energy delta G of a reaction to its equilibrium constant. And this one is delta G is equal to the negative of R, the ideal gas constant, multiplied by T, the temperature, multiplied by the natural log of the equilibrium constant. Number five is the equation delta G, the Gibbs free energy, is equal to delta H, the enthalpy, minus the temperature times delta S, the entropy. And this equation is very useful for determining the sign of the delta G and therefore whether or not a reaction is spontaneous based on the signs of delta H, the enthalpy, and delta S, the entropy. And remember, for this equation, the temperature has to be in Kelvin because the temperature has to be a positive number. Number six is the general equation for the equilibrium constant of a reaction. So if we have a reaction, the equilibrium constant K is equal to the concentration of products divided by the concentration of reactants, where each product and reactant has to be raised to its respective coefficient. So if we have an example where 2A plus B gives C, so A and B are the reactants and C is the products, the equilibrium constant K will be equal to the concentration of C raised to the first power divided by the concentration of A raised to the second power multiplied by the concentration of B raised to the first power. Number seven is the Arrhenius equation, which allows us to calculate the rate constant for a reaction. And this one states K, the rate constant, is equal to A, the frequency factor, multiplied by E raised to the power of negative activation energy, E sub A, divided by R, the gas constant, multiplied by T, the temperature. Now, thankfully, this equation is usually only tested conceptually. Number eight is the equation pH plus POH is equal to 14. Now, keep in mind that this is only true for aqueous solutions, so one where water is the solvent, and at 25 degrees Celsius specifically. However, on the MCAT, that is almost always the case. Number nine is an equation from electrochemistry, and this one relates the delta G of an electrochemical cell to its standard cell potential E. And this one is delta G is equal to the negative of the number of moles of electrons transferred N multiplied by F, Faraday's constant, multiplied by E, the standard cell potential. And finally, at number 10, we have the mathematical statement of the first law of thermodynamics, which states that delta U, the change in internal energy of a system, is equal to Q, the thermal energy that is added or removed from that system, plus W, the work done on or by that system. Now, there are many more equations you will need to know for the MCAT, so make sure to DM us the word equation and we'll send you our free equation sheet. Also, make sure to use the link in the bio to sign up for my free live workshops every Thursday at 8 p.m. EST and 5 p.m. PST, where I go through double AMC passages and talk test-taking strategies. I hope to see you there.